Discover the ideas that will shape tomorrow's world.
What if the very walls around you could, actually fight off germs? We're talking about buildings that practically clean themselves. Today, we're going to dive into how incredibly tiny technology could solve a really big problem for our health. It sounds like a strange question, right? But it's a very real one. Have you ever felt kind of blah at work or at home, only to feel way better the moment you leave? Well, you're probably not imagining it. There's a name for this, and it all starts with these invisible little colonies setting up shop all over our surfaces. See, the real problem isn't just a few stray germs here and there. It's biofilms. And you can see here, these are basically organized cities of bacteria. Seriously, think of them like microscopic communities, and they have this protective gunk that helps them cling to everything from concrete to your computer keyboard. And those biofilms, well, they can lead to this, sick building syndrome. And this isn't some made-up thing. It's recognized by the World Health Organization. This isn't just about catching a cold. It's a real, documented condition where the building itself is a major reason people feel sick. So that really gets us to the heart of the matter. Let's take a closer look at this sickness that could literally be living inside our walls. Look, we can't just keep wiping everything down 24/7. It's just not a real solution. We need something smarter, something more permanent. So the real question is, how do we design surfaces that can actually defend themselves? And this is where the science gets super cool. The answer might be hiding in something so small you can't even see it. It's time to bring in the nanoparticles. So in a recent study, scientists basically set up a fight between 3 different materials. First up, you've got titanium dioxide. Think of it as the reliable old workhorse. It's stable and it's cheap. Then there's copper oxide, which is the powerhouse, known for being a really potent germ killer. And finally, the wild card, a hybrid that's just a simple mix of the first 2. All right, so the stage is set for a bacterial showdown. The researchers had to figure out which of these tiny particles is the ultimate germ-fighting champion. And honestly, the way they designed the test was pretty clever. So the experiment was pretty straightforward, but tough. Over on the left, you see the challenge. They put these materials up against 2 really nasty bacteria, E. coli and Staph aureus. And on the right, you see the goal, to find what's called the minimum inhibitory concentration, or MIC. Basically, that's just the tiniest possible dose you need to completely stop the bacteria from growing. And here's the key. In this competition, lower is better. The lowest score wins. So how in the world do you actually see the results of a microscopic battle? Well, it all comes down to a really simple color change. Take a look. The scientists add this special dye. If one of these little wells turns pink, that means the bacteria are alive and having a party. But if it stays clear, that means our nanoparticles have won the fight. And here we go, the results are in. Remember, on this chart, a lower bar means a better result. So just look at that first bar. Titanium dioxide all by itself did absolutely nothing. No effect. Now, copper oxide, it did pretty well. A really low bar at 0.625. But then look at the hybrid. Whoa. At 0.312, its bar is literally half the size. That means it's twice as powerful as the copper oxide was on its own. Yeah, the data does not lie. When it comes to stopping these tough bacteria dead in their tracks, the hybrid material is, without a doubt, the undisputed champion. Okay, but this is where the story gets even cooler. It's one thing to know what worked, but we really need to understand why it worked. So what was the hybrid's secret sauce? This is the million-dollar question, right? We just saw that titanium dioxide did absolutely nothing by itself, yet when you add it to the powerful copper oxide, the mix suddenly becomes twice as strong. How is that even possible? Well, the answer is this really cool concept called a synergistic effect. And all that means is that when you combine 2 things, the result you get is way, way bigger than you'd expect. It's not just 1 + 1 = 2, it's more like a superhero team-up, where 1 + 1 suddenly equals 3. And you can actually see part of the reason why right here in these microscope images. On the left, you've got the pure titanium dioxide. See how it's all clumpy and stuck together? But now look at the image on the right. That's the hybrid. Its structure is way more varied, more spread out, and that new physical shape created a much, much better weapon against the bacteria. And when they dug even deeper into the science, it was all about the chemistry, down at the atomic level. See, each of these materials has its own unique crystal structure, which they call a phase. And it was the very specific combination of the anatized phase from titanium dioxide and the tenorite phase from copper oxide that created this absolute powerhouse of germ-fighting ability.
Okay, so let's bring this all back home. What does this amazing scientific discovery actually mean for our future? Well, it takes us right back to that big idea we started with, self-disinfecting buildings. So, to quickly recap what we've covered, we started with a problem, right? Bacterial biofilms in our buildings can actually make us sick. Then, we met our nanoparticle contenders and watched as the hybrid came out as the clear winner. And finally, we uncovered its secret, that incredible power of synergy. And hey, this isn't just some fun lab experiment. The researchers themselves wrapped it up with this really powerful statement. They're saying these materials have real potential to control bacteria on the very surfaces we live and work around every single day. So, I'll just leave you with this final thought to chew on. We've just seen the science for surfaces that can actively kill bacteria. The possibilities here are just huge. I mean, what if our hospitals, our schools, our homes, what if the very walls around us could help fight the next pandemic before it ever even gets a chance to start?